Hey, this is Leach with Simpson Math, and in this video, we're going to be talking about using Desmos's update to the normal distribution. So you can find a previous video, which I have linked in the description below, of how I go through a normal distribution set of problems. I cover how to do it by hand, the old Desmos, the 84, Excel, and an internet applet. So on here, just focusing on Desmos's update. So let's take a look at the context we'll be covering. This says IQ scores are normally distributed with a mean of 100 and standard deviation of 15. In shorthand, it looks like this. So notice this format because Desmos kind of emulates it. So we have this capital N is saying it's normally distributed with a mean of 100 and then standard deviation of 15. The first number is the mean, the second number is the standard deviation. And this will let X be the IQ of a randomly selected person. And for our first three examples, we're going to be looking at finding the probability that this randomly selected person's IQ is less than 110. Turns out that's about 75%. Versus, we'll look at see what happens when it's more than 110. So let's hop over to Desmos. Here I have Desmos already kind of set up. I've just turned on blank Desmos and filled this in. I'll show you exactly how to do this. I just wanted you to see the goal. So here we have normal distribution typed in here with a mean of 100 and standard deviation of 15. So notice it follows the same order that we had before. And if you're not sure, it even labels it here. The first number is the mean. The second number is the standard deviation. Well, how did I get this? Let me clear this out and reset the screen. So the best, newest, ideal way to do this is to come up here to this plus, which is add an item, select it, and then we're going to pick the inference one. This is a new thing that Desmos added. It says inference. We're not doing inference, but if you look at the icon, it also just have like a normal distribution. So it's our distributions and inference. They're just trying not to have too many words here. So select inference. All this is inference. We'll cover that in a later video. But we're going to be looking at the probability distribution. So select that. Up pops several options here. First, look at the dropdown. It's default set to what we want, normal distribution. These other are continuous distribution. So this uniform is the continuous version. And then below this line are the discrete distributions. All right, so if you just press create distribution, it'll do it with a grayed out default mean of 0 and standard deviation of 1, which are the z-scores. But I want to put in our values in context, which is a mean of 100 and standard deviation of 15. So just type 100 on the keyboard. You can then click over on standard deviation, or you could just press the tab key to get to the 15. You can press the enter key or click on create distribution. And then it creates it for us. So one, it'll create it and then zoom in. So that's the way to do it. I'm going to quickly run through the two other methods that you could do to get that. The first other method is to just type it in. We see that I want normal, dist, and then my values. So just on a keyboard. I'm on a real computer, so I have access to the letters, the keyboard. So normal, dist. Notice the normal, dist here are all italicized, and Desmos is trying to maybe treat them as variables. But when I put in that T, it snaps to be straight up and down. That's Desmos going, oh, I know what that is. That is the normal distribution. That's the function I know. It's wanting parentheses because that's what functions, how they work. So then I open parentheses. Notice it defaults to a mean of 0, standard deviation of 1, even if it's blank. Let's say I have a distribution that's maybe 75 for the mean and 5 for the standard deviation. So notice this black distribution would be that one. If you press this magnifying glass, it says zoom fit, it'll zoom in to that distribution. I can press this magnifying glass to get back to the one about the IQ scores. So that's how I can manually type it in. The other way is you could open up the functions list. So to the right of my head, or I guess left of my head, there is this show keyboard. You can pop that up, go over to functions, scroll down to probability distributions, and select normal distribution. So notice all these here are the same ones. Many of those are the same ones in the list. Normal distribution, and then you can type in our mean of 100, standard deviation at 15, and then move on with that. All right, so those are all those ways that we can get the normal distribution plugged in. But I want to show that the area less than, so if I'm here at 110, the area less than all that will add up to about 75% or 0.7475. So to do that, I'm going to toggle open this cumulative probability, so spin that open. And now we have some options and it already put some shading in for us. It'll default to just the center. It goes up and down one standard deviation, which is the center 68.3. So that's where these numbers are just by default. Desmos likes to show you how things work, so that way you can then start playing with it instead of you having to guess. So they're showing you, oh, if you put in 85 and 115, this would be our value. Well, I'm wanting to answer again, I'm wanting to find less than 110. So that's an area to the left. So these, my regions are, I have inner, outer, left, and right. I'm going to select left. That's going to adjust this down here to show that I'm looking for x is less than or equal to. It defaults some number. It defaults to the mean. It just puts in the 100 for us, again, showing us how it would work. But I don't want 100. I want 110. So I'm going to type in 110. And even as I type it in, notice it's updating the numbers live, as long as it's valid, and it's outputting what it's equal to here. I'm getting 0.784, sorry, 0.748. I know that might be a little bit small on your screen. So that's the area, that's the shaded region here. You might notice it looks a little bit like a button. That's because it is. There's a little, it's this gray kind of rectangle around it with a triangle. When you click on it, it just opens up more decimal places because you might be needing more than just 3 decimal places, 0.748. You can click on it. It'll spell out a lot more values. Let me zoom in on this just a little bit. I can make that be a bit bigger. There we go. So we can see it spits out more values, and then you can also click on this button right here. This will export it. Notice how the icon is kind of showing you what like a little side screen is here. So when I click on that, it will just copy and paste that value down with a whole lot more decimal places if you needed to do some math with that. Why might you want to do some math? Well, maybe you want to do some math with this number. You maybe want to add, subtract, multiply, divide. So like if I did 1 minus 0.4745, I'm going to get the area above. Let me actually show you how we could do that using this interface here. So if I just switch this to the right, notice how it keeps it at 110, and the area to the right here is this 0.252, or all these decimal places. Notice that 0.252 is this same area here that I was able to do 1 minus to get that math using math. So quick review on those two, that for left and right, we can just we select which way we want. Notice the inequality updates. We can put in our value, and then the output is here. The output is this value. If we click on it, we can see more decimal places, and we can even click on the extra button to add it into its own row so we can do something with that. All right, let's take a look at the next set of questions. So that was a less than 110, greater than 110. All right, now I want to find between 80 and 110. So that one I'm looking for between 80 and 110. All right, so let's go back here and let's do that. So if I'm wanting to find the area between, we can do inner or outer. That inner sounds right. So now I want to find between 80 and 110. So I have 2 blank things. If I delete things out, it's going to, again, like I said, do the standard deviations. But I want to do 80 to 110. So when I typed in 80, it does put something over here. It does give me to infinity. So that way this does kind of work for a right direction. If you wanted to be lazy and not press right, you could just put in the 80. And then I'm going to start typing in the 110. And I'm going to do it slowly so you see what happens. Notice when I put in 1, it actually switches these inequalities to be 80 is greater than or equal to x, which is greater than 1. Again, Desmos wants to work. It's programmers, their programmers made it be so that way they'd rather return something than return an error. So even if you do the non-traditional way of low to high, if you do high to low, it'll still input it. But I'm going to go ahead and do the 110, and notice when I put in the 110, the inequalities will switch to being in the correct order and are less than, so when we type in low to high, it works the right way. So then our answer for that area is that 0.656. Again, if you want more decimal places, do that same process. All right, what's next? I have a little just side conversation that we had in that previous video about finding z-scores. I'm not finding z-scores, referencing the absolute value. So let me go ahead and answer those 2 questions. The first one is, I want to find the area where the probability where the absolute value of z is less than 1. I go through and I talk about how we'll test a few points. It ends up being the area between -1 and +1. If I switch that and do greater than the absolute value of z, or sorry, absolute value of z is greater than 1, it ends up being the area below -1 or the area above 1. So let me just show you how we could find those two areas using, um, using Desmos. So to do that, I'm going to get rid of our normal distribution. Actually, I'm going to just hide it because I'm going to come back to it. So I'm just going to click this button to hide it. I'm going to put in a new one, new inference probability distribution. I'm going to intentionally go ahead and put in the 0, 1, 0, and 1. So that way it shows it there. Or you could have just left it blank and it would have defaulted to it. So this is our z-score distribution here. So this is the normal distribution, the standard normal distribution when we're dealing with z-scores. And then I want to find the area between -1 and 1, and this actually defaults to it. Oops, let me scroll down. There we go. This actually defaults to it with that mean with -1 to 1, but let me go ahead and just type it in, -1 to 1. So the area between those is, between -1 and 1 is about that 68%. And then if I switch to outer, here's how this would work. So this is it says x, I just said z on accident because it's the same thing, but here x is less than or equal to -1, or x is greater than or equal to 1. So we do split this inequality up and use the or statement to glue those two things together. Notice that this 68.3% and this 31.7%, they add up to one whole, as they should. All right. Next, let's switch this around and let's do the inverse process. So I'm going to find the highest IQ among the lowest 20% of scores. So looking at my picture here, I know I want the lowest 20%, and I'm looking for what this value is. In terms of when you do it by hand, just a reminder, you would find the z-score of -0.84 and then solve, but I can just use technology and go directly to it. So let's get rid of this one and turn this one back on and zoom into it. And now, instead of me computing, notice this is compute. Instead of me computing the area, I want to compute the bounds. And also, do you see how my inputs are the values on the x-axis, and my output is this area, or the input is the bounds here, the output's the area. Well, when I switch to bounds, my inputs and outputs switch. My input is the area, and my output are the bounds, or the boundaries on the x-axis. So you can switch, the bounds works for all of these, inner, outer, left, right. There is something special about inner and outer. It's the middle inner or outer. For left and right, let's see which one matches our problem. I want the area to the left. I want the lowest 20%, so let's do the area to the left. This does need to be entered in as a proportion. If I try to type in 20%, it's going to yell at me. And this says the target area needs to be between 0 and 1, so not 20%, but 0.2. So again, Desmos wants to work. So if I leave this blank, notice how Desmos is doing something. So it's just giving you an example that says, hey, try typing in 0.5 and your answer will be 100. So it's trying to give you something to do, so you can kind of test it out that way. I want 20%, 0.2. So the lower 20% here, I'm at my lower 20%. What would that x value be? Well, that x value would be about 87.38. And notice that's where this edge of this red here would be 50, 60, 70, 80, not quite 90, 87.38. Again, just like before, if you click on it, you can get a whole lot more decimal places. Click on this button to export a snapshot to be able to see that value. All right, so the area less, let me pop the question up again so we can see it. Oh, my interface is getting angry at me. Go away, go away. Well, I just moved some things around. There we go. So this says that we were to find the highest IQ among the lowest 20% of IQ scores, and it turns out it's that 87.38. So the highest IQ among the lowest, which always sounds strange. That's because this line right here is the highest IQ among these lowest. So let's switch this and let's find the lowest IQ among the highest 20. So if you're in a room of the highest 20% of IQ scores, and this line that we're finding is the lowest, the dividing line between those two. So to do that, I'm going to look for the area to the right. And the way Desmos works is this input, they try to keep this input to be the same when you switch buttons. So when I switch from left to the right, it keeps that at 0.2. So this is already the top 20% because our two questions were similar. If it wasn't, if it was maybe 25%, you would change it 15%, whatever it is, but it turns out that it's 0.2. And we get this 12.6. Sorry, 112.6. All right. Then lastly, what about the middle 40%? So whenever you're doing these inverse problems where you're given a percent and you need to find the bounds, these typically, if you're finding two values, it has to be the middle 40% because there's actually an infinite number of 40% bounds that we could provide. So these are the middle 40%. So one way to do this, if you're doing it kind of old school way, that we would need to process that if this is the middle 40%, on this end we have 30 and on that end we have 30. I call it the middle percent dance. We have a normal distribution. Everything under the normal curve is 100%. Here's 40, delete it. We have 60 total on the edges, and then half of 60 is 30, so 30 in each. So notice 30 plus 40 plus 30 is the full 100. So old school way, I could figure out what that is by finding the area to the right of 30, oops, not 23, 30 is 107.9. The area to the left of 30 is the 92, sorry, not to the left of 30. The lower 30% would have a cutoff of 92.13. The upper 30% would have a cutoff of 107.9. But I want to find the, so that's one way to work this problem. The other way is we could use these inner-outer buttons. So if I use the inner, and I want to find the inner 40%, notice I get the same values that I found a second ago from the 30, because this inner or outer is stuck to the middle percent. So this is stuck to the middle 40%. So it's doing middle 40%, lower 30, upper 30, and we're getting those values. Again, you can click on them to see the full to see more decimal places. If you did outer, notice that the outer 40, that's not what this question is asking. It would be the outer 60, which would be 30 and 30, which would be those same values. So obviously, if you're working this problem, the most direct way would just be to find the inner 40%. That would be the absolute center of the 40. If you were wanting to find some other 40, you would need to be given one of the inputs, and that's usually more complicated than what we're covering today. All right, so I hope that helped for covering on how to work with the normal distribution. So we learned how to plug in the bounds to get the area, and then plug in the area to get the bounds. Use these different buttons to adjust your settings. When in doubt, just kind of delete what Desmos has, so you can see their example, and then you can plug in your value. All right, I hope this helps, and I'll see you all in the next one. Bye.